It's a beautiful morning. I think I'll go outside for a while. Just smile. Just take it
Ang bango ah.
fresh air. Staying inside. If the weather's fine and you've got the time, it's your chance to wake up and plan another brand new day. Either way, it's a beautiful morning. Each bird keeps singing its own song. So long, I've got to be on my way now. No fun just hanging around. I got to cover ground. You couldn't keep me down. It just ain't no good if the sun shines and you're still inside.
Mami, ang bango mo ng sinasain mo.
Siyempre na, dinagdagan ko yung napanda na pandagdag ng aroma at saka na flavor nung sinain natin. Oo, kumakalipas ka. Ay, bakit?
Ate, nandyan ka ba? Meron si ate ko! Ate, matagal pa ba? Hinihina ako! Hindi ko alam mo, sir! Hala, ate, bakit ang baho? Amoy bulok na itlog! Teka, na-stress ako! Ate!
Mga anak, kain na tayo. Thank you, honey.
Ikaw talaga, ate. Tagal mo kanina.
Bango talaga nito, kaya paborito mo natin.
Ito rin saging, masarap. Paborito ko dito, no?
Oo nga na sinain mo, Mami. Amoy pandal nga.
Ay, ate, tignan mo to. Matamis. Mabango pa. Aral-aral pa, kaya ka walang love life. Uy, may tao. Ate, may tao. Hi!
Hi, best friend!
Hello.
No Time TV, ang ganda ng palabas ngayon. Related sa topic natin sa food chemistry.
Talaga? Sige, upo ka. Uy, ate, tawagin mo si Mami tsaka si Daddy.
Mami, Daddy, ko.
Time TV.
Sige.
Ako na lang magbubukas.
Buksan na yan.
Ma! Si Jake! Tuloy ka, Jake!
Good afternoon po.
Kapi ka muna.
Cream? Dapat black, para po balansin. Dapat, kabilang. Dapat po, may konting sweet. Dapat, matapag lagi. Dapat po suwabe.
Anumang timpla mo, kuwang-kuwa ng Nescafe Classic, gawa sa pinakapiling coffee bean.
Dapat, kung ano yung gusto mo, yun yung sabihin mo.
Yan dapat!
Anumang timpla, kuwang-kuha.
Ang susunod na programa ay Rated G. Ito ay pwede sa lahat ng manonood.
The mystery behind flavors and aroma. Like any other system in the human body, the sense of smell and taste are also an extremely complex design. Now, let's examine more closely the various parts of the system. Your tongue is covered in tiny little bumps called papillae that each contain many taste buds. Chemicals from the food dissolve in our saliva before they enter our taste buds through the taste bulb. These chemicals will then reach the receptor of the receptor cells. Different chemicals give different tastes. A taste bud contains several taste receptor cells. Each receptor cell is more sensitive to a certain flavor. At the end of each receptor cell is a tiny hair that can sense the chemical from the food. When the chemical enters your taste receptor cell, the taste receptor sends a message to the brain via the afferent nerve. The brain processes the messages it receives and allows us to perceive the taste of food. Do remember that our taste buds do not taste, they only send signals to the brain. It is your brain responsible for taste. Olfactory receptor cells are like taste receptor cells, but they are found in the uppermost part of the nose. The receptor cell also has tiny microscopic hairs on one end and is connected to the brain on the other end. Different smells produce different chemicals that enter our nose that we breathe in. The microscopic hairs in the olfactory receptor will detect the chemical. The receptor will pass a signal to the brain for processing. Our brain processes the signal from the nose and allows us to perceive smell. Without it, our nose can detect chemicals, but we will not know what we are smelling. Our sense of taste and smell work together to enable us to enjoy food. The parts of the brain that control smell and taste are closely linked. When you chew food, the food releases certain odor and chemicals to travel up your nose from your mouth. This causes your brain to receive messages from both taste and olfactory receptor cells. Now, let's think about the big mystery in chemistry why compounds in food are called aroma compounds. Consider the benzene molecule C6H6. Each carbon atom is sp2 hybridized and forms sigma bonds with two adjacent carbon atoms and another sigma bond with a hydrogen atom. The 6 2pz orbitals form pi bonds. Electrons in these pi orbitals are actually free to move around to enter benzene rings. Orbitals of this type are called molecularly delocalized.